A very good morning and a warm welcome to one and all present here. It's our absolute pleasure to welcome you all for today's Polymer Engineering Across Borders, a Global Alumni Webinar. We are delighted to have our distinguished chief guests, esteemed faculties, and enthusiastic students joined us for this insightful and enriching event. Today we embark on a stimulating national journey filled with beneficial wishes and exciting opportunities. Let's approach this webinar with an open mind and a spirit of curiosity, eager to learn, discuss, and explore new horizons. Now, with great respect, I invite our respected head of the department, Dr. S. Samshad Begum Ma'am, a guiding light in our academic journey and a pillar of our success, to deliver the welcome address.
Good morning, everyone. It is both an honor and a privilege to welcome each of you to today's virtual session of the Polymer Engineering Across Borders, a Global Alumni Webinar Series 2, hosted by our Department School of Mechanical Sciences. I would like to begin by expressing my sincere gratitude to Dr. Muhammed Ali, Senior Lecturer at the Fuel Cell Institute, Universiti Kebangsaan, Malaysia, for graciously agreeing to join us as our distinguished speaker for today's event. Dr. Ali, we are truly honored to have you with us and look forward to your valuable insights. Welcome, Ali. It is a privilege to welcome Dr. S.M. Abdul Majid, Professor and Director of Admissions. Your exceptional work in streamlining the admission process and attracting the top-tier talent has been integral to the success of our institution. Your contributions are deeply appreciated. And I would also like to take this opportunity to acknowledge Dr. Shahida Parvin, the coordinator of this second series. My sincere thanks also go to my esteemed colleagues, Dr. Pundi Srinivasan, Dr. Basanta Kumar Behra, Mrs. R. Daulat Banu, and Mrs. J. Daphne for their continuous support. Finally, a warm welcome to all of our students whose enthusiasm and engagement make events like this truly special. As we gather today, let us look forward to an enriching and intellectually stimulating experience. This webinar promises to offer a wealth of knowledge, foster meaningful discussions, and provide invaluable networking opportunities. Thank you and hope you all find this session both rewarding and memorable. Welcome all.
Thank you, ma'am. With a great honor, I now welcome our Professor and Director Admissions, Dr. S.M. Abdul Majid Sir, a passionate advocate for education and a dedicated mentor to offer the felicitation address.
Good morning, everyone. I am very happy to associate with all of you in this the outstanding program, that is the Polymer Engineering Across Borders, a Global Alumni Webinar Series 2 today. Dear students, you all know that the lithium-ion battery have aided the revolution in microelectronics, especially in portable devices, and recently it is taking a very significant part in the electric vehicles. Nobody can imagine the electric vehicle without using the lithium-ion batteries. So in this respect, this topic is highly significant one for the students of polymer engineering, because fortunately, for the development of this lithium-ion battery, so many different kinds of polymeric materials are used. So the development of such kind of technology is going on, improving the significance of this polymeric materials for the growth of all kind of engineering and technology. When coming to the today's speaker, Dr. Muhammed Ali, it is a proud moment for me. I feel proud that I am the professor for Dr. Muhammed Ali. Muhammad Ali, when he was the student in our department, he was a very enthusiastic student. He did active learning almost all the 4-year program in our campus. I take this opportunity to congratulate Dr. Muhammad Ali for his outstanding position in various universities. So one more happiness I have because the Muhammad Ali is following our profession. It is a noble profession, the teaching the students and sharing the knowledge we acquire to our human community. In this respect, when compared with so many alumni, he is a very significant person because he has chosen the teaching as his passion. So congratulations, Dr. Muhammad Ali. I am very happy to see him today, and probably in future he may be visiting our university. We can have the direct interaction with him also. In this few words, I take this opportunity to congratulate the head of the department, Dr. Samshad Begum, for taking this kind of initiative to bridge. Actually, this topic of this program is the bridging the lithium-ion battery technology and polymer technology. But actually, this kind of seminar is bridging the current students of our department with the alumni of our department. So I am very happy to participate along with all of you students today. Thank you. Thank you, one and all.
Thank you, sir. Now I request the faculty coordinator, Dr. J. Shahita Parveen Ma'am, an enthusiastic motivator to our student community, to introduce our distinguished chief guest for the day.
Here to introduce our distinguished speakers, Dr. Muhammed Ali, Senior Lecturer, Fuel Cell Institute, Universiti Kebangsaan, Malaysia. Dr. Muhammed Ali received his B.Tech in Polymer Technology from Crescent Engineering College in 2006. He then completed his Master's in Fuel Cell Engineering in 2014, followed by a PhD degree in the same field from Universiti Kebangsaan, Malaysia in 2018. Before continuing his postgraduate studies, Dr. Muhammed Ali worked as a production engineer at Enercon India Limited and as a quality assurance engineer at Behrin Fiberglass International. Currently, he is a senior lecturer at the Fuel Cell Institute, Universiti Kebangsaan, Malaysia. Dr. Ali's research focuses on fuel cell, electrolyzer, photodegradation, wastewater treatment, oxygen transport membrane, and CO2 conversion and utilization. He has been awarded the ISDP Postdoctoral Research Scholarship in Saudi Arabia and the Malaysian International Scholarship from the Ministry of Higher Education, Malaysia. He has also secured several research grants and has co-authored over 60 publications indexing Web of Science and Scopus. In addition, I'm proud to say that Dr. Muhammed Ali serves as a reviewer for several prestigious journals, including Ceramics, International, Ionics, International Journal of Hydrogen Energy, and the Royal Society of Chemistry. I'm happy to invite you, Dr. Muhammed Ali. Thank you, one and all.
Thank you, ma'am. It is now time for the most awaited session of the day. We are privileged to welcome our chief guest, Dr. Muhammed Ali SP, as he shares his insightful address on bridging polymer technology and fuel cells technology for a sustainable future. We encourage everyone to actively engage in this session.
Shall we start?
Yes, you can start.
Okay. Assalamu alaikum warahmatullahi wabarakatuh, and very good morning to all. Before I would like to start my presentation, I would like to thank the members of Polymer Engineering Department and also the School of Mechanical Science. I would like to extend a much better gratitude to Professor Abdul Majid. His introduction about me was I have moved on actually, like it touched deep that he gave a very nice introduction about me. I was surprised that Abdul Majid still remembered me, even though I have passed in the year of 2006. Unfortunately, I was not able to meet Prof. Abdul Majid last year, February, when I visited Crescent Engineering College. I came on Friday to meet Dr. Shaida Parveen. We had some collaborative research work going on. So I visited India to meet my family, and then I choose one day to visit Crescent Engineering College. Since it was on Friday, and then and also it was on a carnival day, I feel. I'm not sure whether it's a carnival day or a college day. So Prof. Majid was a little busy, then I could not able to meet him. And it was an unfortunate incident. But I went to the lab and I met a few lecturers, and also I visited mechanical department, and I discussed with the HOD of mechanical department, and we had a very fruitful uh, discussion on the research collaborations. Okay, I will also like to extend my deep thank you to the HOD of Polymer Engineering, Dr. Shamsad Beham. I, if I'm not mistaken, we haven't met. Doctor, am I right? This is the first time I think we are meeting
Yes,
on Zoom.
Mr.
Okay. Inshallah, when I come next time, I hope we can meet and then we can discuss more in detail about the collaboration and networking between us.
Amen.
Okay, thank you. And I'm very happy that present from means Crescent Engineering College, the Department of Polymer Engineering and School of Mechanical Science, and combined with the alumni from Crescent and also from Polymer are organizing such a series. I'm deeply touched. I always encourage that to conduct such webinars. You know, now the technology has so much have improved, so conducting such webinars in short notice is quite possible. No need to plan for 6 months to 1 year to conduct a conference or workshops. Now just in 1 week or 2 weeks we can organize such a webinar, and then we can uh, discuss, and also we can collaborate. And also, I would like to thank the student coordinators, Nitin Srinivasan and Sweta Mariappan, for organizing this wonderful webinar. Okay, without further delay, I would like to go into our topic. Let me share my slides first.
Yes.
Okay. Ready? Let's start. Before we start our today's topic, I would like to start with a short story. When I started my talk, we are talking about some kind of collaborations and networking, right? So similar to that, what if uh, uh, when you go and visit people, for example, you go for a workshop or a conference, and then you get into networking, right? And then you start to do research, and then you start to ask questions. So you might be in the third year or in your fourth year of your degree program, or you will be in the 6 semesters or doing your project. So you have some doubts. So when you go to conferences and networking, you ask questions so that you can clear your ideas or clear your queries. What if like you have to start identifying the problems uh, surrounding you actually. For example, when you are uh, doing some cooking in your from your kitchen, and then and you forgot about the cooking, and then you left it over and it got burnt. So what is the scenario in it? So means you have burnt your food. So if you overall you look at the process, you means you started a cooking and then you spoil the cooking, right? That is how the normal people think, how the researchers or the scientists should think. So when you burn the food, it forms into carbon, right? So the carbon for us is a material. It's not a waste. For others, it's a waste. For normal people, for example, your mom or your mother may think it's a waste. But for us, it is not a waste. It's a carbon. So you can bring those carbon to your lab and you can study its microstructure. You can study on its properties. So this is where you find some solutions to the existing problems. So how we are going to find the existing problems, what I'm facing in fuel cells, how we are going to bridge that problems by integrating polymer engineering into it. So always you think for an real life problems and you start seeing your surroundings to solve it. So that's what I would like to say. Okay. Before that, I would like to, before going into the topic, I want to tell you that uh, even though if you are in the second year, third year, or the fourth year, always try to attend at least one conference or in workshops. Uh, make it a mandatory, even though if the degree doesn't say that it's mandatory to attend a conference, but I would recommend that you attend conferences either within India or overseas conferences. Mm. So it always helps you to get into knowing people, and also it will helps you to build your networks. Okay. Today I'm going to present an exciting topic where we are going to combine the polymer technology and fuel cell technology for a sustainable future. And my name is Muhammed Ali from Universiti Kebangsaan, Malaysia. So we can translate the Universiti Kebangsaan, Malaysia to the National University of Malaysia. So it's one of the biggest university in Malaysia. It's ranks number 2 in within Malaysia. So I will detail them as we go into our topic. So so I have organized my talk based on these headlines. So what we will do is we will explore how polymers plays a vital role in advancing SOFCs. So this synergies of polymer and fuel cells can contribute to a sustainable future. So are you ready to know about these technologies? Okay. So so I have organized my talk. First, I will give you a short introduction about UKM and the Fuel Cell Institute. Then we will start to know about the fuel cell technology, followed by the introduction of solid oxide fuel cells. Then we will discuss on the role of polymers in SOFCs, and we will discuss slightly about uh, potential projects and opportunities, and finally the summary. So the main objective of this talk is to make you all understand the fundamentals of fuel cell technology, and to learn why polymers plays a pivotal role in advancing the fuel cell applications, and how polymers contributes to the advanced SOFC fabrications, and also on the performance of fuel cells. Then I would like to, towards the end of the talk, I would like to, maybe I will be successful in motivating you all in considering a career in fuel cells and also in the energy materials. Okay. So before that, I would like to give a short education and professional background about me. Dr. Shahida Parvin have read about my introduction, but still I would like to introduce myself again. So I did my polymer technology. Now it's called as polymer engineering, right? Okay.
Yes, yes.
So when we were during our time from 2002 to 2006, when I did polymer from Crescent, it's called as polymer technology. So I finished my degree in 2006, and then immediately I joined Agarwal Rubbers Limited, Hyderabad, Andhra Pradesh, as an assistant production engineer. I worked there for 3 months. Uh, Maybe because of homesick, I'm not sure. I left the job and I came back. Then after staying for a few months in home, I felt that I made a mistake of uh, of resigning the job from Agarwal Rubbers. So I immediately applied, and then I got as a production engineer in Enercon India Limited. So Enercon India Limited is a German company where they make windmill blades. They not only make windmill blades, but also they make capsules for the wind mills, and also they do site commissioning and also installation and also maintenance. It's a complete package. It's a big company, but now it's no more called as Enercon India. It's called as Wind World India Limited. So you can Google them. So from there, I moved to BFG International Kingdom of Bahrain. There I worked as a quality assurance engineer for 3 years. Then after very after long discussion, then I decided to continue my studies from the National University of Malaysia, UKM, majoring in fuel cells engineering. So I did my master's and PhD from 2011 to 2017. So from 2018 until now, I'm working as a senior lecturer or a research fellow at the National University of Malaysia. So I highlighted all these companies in bold so that you, if you're thinking of identifying some companies and to apply, so you can go for it. This BFG International, particularly this BFG International, it's originally from Kingdom of Bahrain, but now they are all over the world. Even they have a plant in India in Tada. Have you come across BFG International any time soon? So if you don't know about the company, you can Google them. So they are in India also. Though mainly they make FRP parts. So they do all kind of FRP materials. Um, base, if I'm not wrong, I think they are making the FRP panels for our metro rails at present. So they are also in US, they are also in Canada, they are also in South Africa, Philippines, then where else? In China, yeah, they are in China. Everywhere they are uh, worldwide, so you can apply. They have lots of opportunities, so you can work. And a few of your seniors are still working in BFG. Okay, so that's all about me. So if you have any questions, so you can contact me through my mobile number. So this is my personal mobile number. You can call me anytime, or you can text me via WhatsApp. So I have given my official email ID and also my personal email ID. So you can email me anytime. And also I have provided my LinkedIn site, so you can search for me. Okay, so this is before going to the topic, let's be some like a formal, let it be like a formal um, discussion about my universities here in Malaysia. So this particular university is established in 1970. It is located with around 1,700 hectares, so which is equivalent to 2,700 acres of land. Total, we have around 17,700 students, which contributes 65% of UG and 35% of PG students. Among them, we have around 6,300 international students, whereas PG students contributes more in terms of international students. And also we have around 2,500 faculty staffs, excluding the administrative staffs. This is only the faculty staffs. So around 20% are international staffs. So considering the UK QS World Ranking, World University Ranking, so we rank 138 in the world and number 5 in Southeast Asia ranking and 28 in Asia ranking. So you can find us. Okay, so this is the campus. So you can see my pointer, right? So this is our overview of our campus. It's a very greenish campus, like our Crescent Engineering College. So when I visited last year, I saw they've cut down some trees. It's okay, but so this is quite very greenish campus, and we are located around 45 kilometers from the international airport and 30 kilometers from the Kuala Lumpur. So we have around 3 different campuses. So I'm from the main campus, which is located here. And then we have one campus at Kuala Lumpur. So basically they do kind of nursing courses here. And here in Charas, which is 20 kilometers from the city, Kuala Lumpur. So they do, it's a for medical. So they have a campus for medical also. So total we have 3 different campuses around the city. So I'm from the Fuel Cell Institute. So there are different types of institutes within the universities. So this kind of institutes are established in order to focus only on research. So normally we recruit students in masters and PhD for masters and PhDs. So we don't teach bachelor students. So we fully focused on research. So we have different groups, and we focus on different types of fuel cells, and also we focus on system-oriented researches. So these are the different groups, and this particular institute was established in 2007 within the university. Okay, so this is some of the pictures from the SOFC group. So you can find me here. So this is so we have around very young, hardworking, and enthusiastic students. So then we also conduct seminars where students present in front of the faculty members. So we always encourage students to present ideas in front of us for every 1 month. Every 1 month or every 2 months, we organize seminars, and then okay, so that students, if students have any difficulties in the lab, so we do some kind of brainstorming sessions. So for that purpose, we encourage students to present. Okay. From the institute, as I said, we recruit students for masters and PhD programs. So we do by research mode for PhD and masters in fuel cell engineering, and also for hydrogen energy. And also we have Master of Science for low carbon and hydrogen technology. So this is purely a coursework. So for the 4th semester, you will do some mini project in order to submit your thesis. So this is all about UK. Okay. So I hope you liked the university. Okay. Okay. So today's topic is on fuel cells, right? So, and also how we are going to bridge the fuel cells into polymer technology. So, but before that, you should know about what is fuel cells. Maybe you would have heard about fuel cells from here and there, right? Maybe we have seen fuel cell cars or fuel cell buses, where hydrogen is used as a fuel. So you might be knowing about the fuel cells, but you don't know exactly or understand how the fuel cell works. So I will I will try to give some fundamental idea about fuel cells so that it will make you aware of the future technology. So by definition, a fuel cell is an electrochemical device that converts chemical energy directly into electrical energy. So when we say directly, it means there is no intermediate step. So that's why we say when you supply chemical energy, is directly converted into electrical energy. How we can compare the fuel cells? So you can compare with the battery. Battery is also battery is also an electrochemical device, right? But what battery does? It stores energy, whereas fuel cell don't store energy. As long as you supply chemical in terms of air and oxygen, it will supply electricity. Okay, so in that case, it works as a combustion engine. So when you petrol your car, the car runs. When petrol finishes, car stops. Same way. So as long as you supply chemical energy, it directly converts into electrical energy. So this particular fuel cell was invented in 1838 by William Grew. So he termed his invention as a gas voltaic battery. So he didn't call his invention as fuel cell, whereas Charles Langer and Ludwig Mond in 1889, they termed as a fuel cell. So what is the major advantage of fuel cells over combustion engines? So it can directly convert from chemical energy to electrical energy. So whereas in combustion engines, it has multiple steps, and also it's have environmental impact. When you combust fossil fuels, it gives us harmful emissions. Whereas in fuel cells, when you burn the chemical energy to electrical energy, the byproduct is water and also heat. And this particular technology don't depend on fossil fuels. It's an independent or sustainable device to produce electricity. So how fuel cell works? So fuel cell converts electrical energy, chemical energy into electrical energy, and this process is called as electrochemical reaction. So in contrast to batteries, fuel cell does not store energy, but it converts. Okay, it directly converts. And during the electrochemical process, the the fuel is not burned, but it is converted. So, for example, when you use a petrol or a diesel, the fuel is burned, and then you get carbon monoxide or nitrous oxide as a harmful gases, right? So these from these gases you cannot produce petrol, right? So whereas when you supply hydrogen and oxygen to fuel cells, the byproduct is water. So you can collect this water and then you can produce or you can convert the water into hydrogen and oxygen again through electrolysis process. Okay, that is me. That is what it means that fuel is not burned. It's just converted, and it follows the first law of thermodynamics, where energy can neither be created or not destroyed. It can be transformed to different forms. So it follows the principle of first law of thermodynamics. So there are different types of fuel cells. So based on the type of electrolyte materials we use, so you can differentiate its types. So when we use ceramic based uh, electrolytes, it have higher efficiency and also have higher applications compared to the polymer based fuel cells or proton exchange membrane fuel cells. So they normally work at room temperature, and then they are suitable for portable applications or small applications. For example, polymer electrode membrane fuel cells, you can use it for automobile in the industries, whereas solid oxide fuel cells or molten carbonate fuel cell, which operates at very high temperature, above 600 to 1000 degrees Celsius. So mainly it's used for stationary and also for higher output. So this is these are the different types of fuel cells. Okay, so normally when we are designing a fuel cells, we consider power, efficiency, and lifetime. So these are the factors which we always consider. So this factor is also depend on the type of fuel cells and also on the type of fuels we use. So if you need more power, so you can add more number of cells. I would like to show the fuel cells which I have here. So this is, can you see? So this is a fuel cell, but it's not a complete fuel cell. Can you see that? So this is a fuel cell, which is a single cell actually. We call this as a single cell. So you can fabricate this single cell of this size and also of this size. So it depends on the nature of your output. You can fabricate them into different shapes. Not different shapes is very limited. Different sizes you can do, but producing of this size is quite easier compared to this. So here where the polymer plays an important role. I will explain that in my future slides. Okay. So this is we call as a button cell, and then we can produce 1 watt of power from here. And this size is 10 into 10, 10 centimeter into 10 centimeter. So you can produce around 7 to 8 watts of power. So this is how fuel cell looks. But I cannot bring a stack. When we combine number of cells, we call it as a stack. Of course, it's heavy. I cannot bring it over here. So if you see a fuel cell stack, what will be inside? These things will be inside. These things. Okay. Okay. And if you need higher long time to use, if you want to use fuel cell for longer duration, then you have to increase your tank. For example, you want more water in your house, then you have bigger tanks, right? Similar way, if you need a higher capacity, then you have to increase the size of your fuel tank. Okay, so move on to the next slide. So there are a few factors which affects the performance of fuel cells. One is the operating conditions, where we talk about temperature, pressure, and gas composition. So in order to operate fuel cells, we have to increase its temperature to an required required temperature, and then we have to apply our fuel in a required pressure and also your gas composition. When we talk about gas composition, we are talking about the oxygen and hydrogen composition. Okay, so this conditions greatly influence and also affects the performance of fuel cells. The next category is the materials. So where the material scientists comes into a major play. So scientists like us, researchers like us, plays a major role here. So when we want to choose our electrode or electrolyte materials, so we have to make sure the material properties of that particular material, whether this particular material is suitable for electrolytes or for anodes or for cathodes. So by considering the or to understanding the requirements of these materials, we can improve its performance and also the cell design. Like I said, the geometry and also the microstructure of the electrodes, whereas the thickness or the composition of the electrolytes also plays a major role in when it comes to performance. So this particular graph I have shown here, where on the y-axis it's a voltage, on the x-axis is current density, and this dotted line is the actual curve. Okay, the performance curve. Whereas this is the solid line on top. This is a theoretical value. So this dotted line is called the voltage loss curve, where we say IV curves. IV curve. So each loss is can be subjected to different components. For example, when we talk about the activation loss, it's always contributed by the overall cell, or especially when you start, there will be some loss of energy, right? So any process, when you want to initiate a process, when you want to run, or when you want to switch on even if your car, you want to switch on your car, there will be some kind of loss in the energy, right? So that region is called the activation loss. This activation loss should be very minimum, so that we can increase the region of ohmic losses. This ohmic loss is majorly contributed by the electrolytes, whereas the region of concentration voltage loss is basically from the electrodes. So I have been talking about cathode, anode, electrolytes, right? Maybe I haven't introduced those components, right? So I will introduce those components in my next slides. Okay. So let me introduce about solid oxide fuel cells. Same like fuel cells, how fuel cell works, solid oxide fuel cells also works the same way. So it converts the chemical energy into electrical energy, where we have an anode and a cathode separated by electrolyte. So this is the electrolyte material, this is the cathode and anode. So this is a typical example of an anode supported. So the one I'm showing you here is the electrolyte supported. So the white part you see here, so this is the electrolyte, and you see the green color part here. This is the anode, and then the black part is the cathode. So you can design your cells on anode supported cell, or an electrolyte supported cell, or a cathode supported cell. So preferably people always look into anode supported cell, but when it comes to fabrications, ease of fabrications or ease of manufacturing, people go for electrolyte supported cells. So what happens at the cathode? Reduction happens at the cathode. So when we supply oxygen, cathode gets reduced, and then that means it accepts electron. Okay. Whereas on the anode, oxidation happens. So that means it loses electron. I can give you a lifetime example, real life example, like when you see the rusting on the iron rods, right? So what happens? It forms iron oxide. That iron oxide happens because it chemically reacts with the oxygen. That is because iron can lose electrons. That is the oxidation process. Okay, so so that is the best example I can give you what related to oxidation. So you can when there is a loss of electron, rust forms. Okay. What are the main advantage of solid oxide fuel cells? It have a higher efficiency, above 80%, and fuel flexibility compared to the other fuel cells. Since solid oxide fuel cells operates at very high temperature, between 800 to 1000 degrees Celsius, so you can use hydrocarbon fuels too. You no need to go for high pure hydrogens to run solid oxide fuel cells. And then we no need to have noble catalytic materials like platinum or gold for solid oxide fuel cells. Whereas the room temperature fuel cells, of course, we need platinum as an coating material to improve the catalytic activity. And this particular fuel cells, they have excellent tolerance towards carbon monoxide. poisoning, especially when you are using fossil fuels or hydrocarbon-based fuels. So the overall reaction of SOFC is when you supply hydrogen, oxygen, it gives us water plus heat. Okay. So there are different types of solid oxide fuel cells is based on the movement of ions. So we can have oxide ion conducting electrolytes. That means when the oxygen is supplied to the anode, it gets reduced and then it travels from the cathode to the anode, where it reacts with the proton to produce water. And okay, so this is called oxide ion conducting. When oxide ions travel from cathode to the anode, if a proton from anode and it travels to the cathode through the electrolyte, it's called proton conducting electrolytes. So it's differentiated based on the movement of ions. And also we can classify solid oxide fuel cells based on the operating temperatures. For example, when we operate SOFC at higher temperatures, 800 to 1000, we call them high temperature SOFC. Then we also have intermediate temperature SOFCs, which operates between 600 to 800 degrees Celsius. And then we have low temperature SOFCs, 400 to 600 degrees Celsius. Okay, so these are the different types of solid oxide fuel cells. And then when it comes to applications, we can use them for residential, commercial, or industrial purpose, and also for the transportation. For transportations, we cannot use for high temperature solid oxide fuel cells. We can use the low temperature solid oxide fuel cells. Whereas for residential and commercial applications, we can go for high temperature solid oxide fuel cells. And these are some of the example solid oxide fuel cells modules which are already available, means commercially available. Of course, it's quite expensive. Maybe we are talking about in millions of USD. So it's the technology is matured enough to be commercialized, but affordable when it comes to owning them. It will take time unless the government gives some subsidies or the government makes some new policies, then it is feasible. Okay. In India, we get subsidies, right, for buying EV vehicles. Am I right? Yes. So similar way, if the government initiates or gives some subsidies to buy these fuel cells for our residential applications, you can forget about your electricity bill. So you can produce your own electricity, and it will run like a generator. Then you have to supply only hydrogen and oxygen. Then you can produce your own electricity for your residential applications. Okay, so we have seen, we have understood the fundamentals of fuel cells and solid oxide fuel cells, but we need to know what are the components and its requirements. So there are different components in the SOFC. So this is the major components I'm talking about. We have other system-related components, or we have reformers, and also we have cooling systems. I'm not talking about all those stuff. We are going to talk about only on the components of the fuel cell related to SOFC. So we have an anode and a cathode, which is separated by a dense electrolyte, and also we have interconnects and sealants. Sealants is something related to preventing leakages. So we will discuss in detail about each components. So basically, when we talk about cathode, it's called as air electrode, whereas anode is called as fuel electrode. Because at the cathode, we supply air. At the anode, we supply hydrogen. So what happens when an oxygen and hydrogen mix together under given temperature and pressure? It's dangerous, right? It creates a bomb. So to prevent that, so that's where electrolyte comes into a major play. So to avoid the mixing of two gases, so we make sure we use electrolyte which is more dense. At the same time, it should not have a relationship with the hydrogen, just for fun. Okay. Okay, so this is about cathode. So what are the major functional aspect of a cathode? Is to provide active sites. So when we talk about active sites, we are talking about oxygen vacancies there. So when you are designing or when you are considering the material for when we are considering a material for cathode, your cathode material should have adequate number of oxygen vacancies. So that will help to provide active sites for the reduction of oxygen. So when we talk about oxygen vacancies, we are talking about defects. Okay. So if you have a defect in any of your product, of when you're going to buy any items, then if you find any defects, what you will do? You will not buy, right? We will not buy, right? But in fuel cells, we purposely create these defects. We need defects in fuel cells. That's the beauty of fuel cells. Huh? So we have to create defects in fuel cells in order to create more oxygen vacancies, which provides active sites for the reduction of oxygen. So what happens? It will react with electrons to form oxygen ions from the external circuit. So electrons comes to the cathode side through the external circuit, which reacts with the oxidants, that is oxygen, to form oxygen ions. So basically, when you are considering a cathode material, the cathode material should have high electronic conductivity and also high ionic conductivity, because your material have to intake the electrons, right? If it is insulating material, then cannot use. So your material, cathode material, should be high electronic conducting material, and also at the same time, it should have high ionic conductivity also. So it's like a mixed. So we call them mixed ionic electronic conducting material. So it has to perform conducting material and also as a non-conducting material. Huh? But it should be 50-50. It should not some electron conductivity should not be more or compromising on the oxide ion conducting properties. And at the same time, your cathode should be porous. You see here, can you see from the micrograph that I have shown some porosity, right? So it should be nearly 30 to 40% porosity, and it should be chemically compatible with other materials, because we are talking about it's a sandwich structure, right? Electrolyte and anode and cathode. So if there is any chemical reaction at this surface, so we'll have delaminations. So mechanically it will fail. So to avoid that, it should be chemically compatible. At the same time, mechanical, and also it should not react with the electrolyte and form new compounds. So that also will affect the performance. And chemical stability. Chemical stability, when we are performing under the fuel cell operating conditions, it should not form new components. Then it can reduce the performance of our materials. And mechanically, it should be stable. So these are the important requirements of cathode. Same way for anode, it should be porous, and it should have high electronic conductivity. Here, it should not have ionic conduction. Maybe you can have minimum ionic conductivity, but electronic conductivity should be more. So what happens at the anode? It should provide active sites for the oxidation of hydrogen. Uh, and also it should provide some facilities to fuel access and also for the product removal. So these are the important functional aspect of the anode. And it should have good porosity, as I shown in the micrograph, and good chemical stability or compatibility, and also high mechanical strength. That is the major requirement of anode. For the electrolyte, it should be purely insulating material, and this particular electrolyte, it acts as an heart of the SOFC. So this is the main part. So where it separates the oxygen ions from the cathode to the anode, means it forms as a bridge. It moves the oxide ions from the cathode to the anode, and completely suppressing or avoiding the transport of protons from the anode to the cathode side, unless it's a proton conducting electrolyte materials. So this is a requirement for the oxide ion conducting material. So this particular electrolyte material should have low electronic conductivity. That is, means 100% insulating material. As long as it is purely insulating material, it's well good. And also it should have high ionic conductivity so that we can reduce the ohmic resistance. And when we are talking about electrolyte, we have to think about its thickness. That is a major factor we have to consider. If more the thickness, more the time takes, and ohmic loss will be more. So to avoid that, so we have to make thin electrolyte as much as possible. So when we talk about thin electrolyte, we are talking about 20 microns to 100 microns range, not in mm, in microns. We are talking about in microns. When we are talking about portable applications, we are talking about in nanoscale thickness of electrolyte materials. So to produce these thin electrolyte materials, it's very challenging. But combining polymers and advanced techniques, it can be achieved. We will discuss on that. Okay. So interconnects is mainly made up of stainless steel. When we are operating solid oxide fuel cells at lower temperatures, when we are operating in higher temperatures like 800 to thousands, then we have to choose ceramic based interconnects. So when we are talking about ceramic based interconnects, of course, manufacturing cost will be high, right? So that is a major setback or a drawback for solid oxide fuel cells when you operate at higher temperature. So we are doing research in order to reduce the operating temperature. When we reduce the operating temperature, we can go for different materials such as stainless steels and then non-ceramic based interconnects. So it's easy to machine. It's easy to machine. So if you see here, can you see some lines on the interconnects? These are called as flow channels. So where we supply our gases and also removal of our byproducts like water or other byproducts. It helps to remove. And this interconnects also helps as an electrical connection between the cells. So when the electricity is produced, we have to take it out, right, to the external circuit. So this will act as a collection point. So when the electrochemical reaction finishes, we produce electricity, and this particular interconnects will act as a collection point, and also it will provide mechanical strength. When we are talking about stacks, so means when you have stacks, there will be lots of pressure, right, on the cells. To avoid the pressure, so the load, the barrier will be withstand by the interconnects. So that is the main purpose of the interconnects. When it comes to sealants, so sealants is helps to maintain the integrity of the cell, which will helps to prevent gas leakage, and also it will ensure some electrical insulation. And most important is safety of the system. So this particular sealant will, when we are stacking, so this is the cathode, and here comes the anode, right? Cathode cannot, right? So we have cathode, electrolyte, anode. Then the other cell comes cathode, electrolyte, anode. So that means when you're talking about anode and cathode next to next, means oxygen and hydrogen can mix together, right? To avoid that, we need to have sealants in between. So we can call this some of the examples. I can show some example of the sealant. Can you see the sealants here? So this particular sealant is made up of glass and polymer. You know how much cost this one? This simple ring, 10,000 rupees. And this one is made up of mica. This is cost very cheap. This is maybe 3,000 rupees. It's cheap compared to this. That's it. But you know, this one, it's very brittle, very, very brittle. It can easily break. If I drop now, I'm losing 10,000 rupees like this. Finish. That's it. So why it is so brittle? Because this particular material, it's not sintered. It's not a complete product. Understand? This is not a complete product now. This is where when you put into the fuel cell and then we heat them, right? It gets melted and then it seals. And then when it reaches the adequate temperature, it solidifies again. It becomes solid again. Understand? It crystallizes. Crystallization happens. So that is the main purpose of the sealants. Huh? So when I say melting, what melts? Polymer melts, right? Organic material melts. So this is polymer, huh? Very expensive. Okay. Okay. So what are the main requirement of the sealants? It should have high thermal stability and then thermal cycling resistance. When you talk about thermal cycling resistance, fuel cell is not something like continuously running. Like car, you go to one point and then you start and then you stop, right? Same way, fuel cells can be switched on and off. So when you on, it will increase the temperature. When you off, it decreases in temperature. So when you are selecting and sealing material, it has to go for thousands of cycles of on and off, on and off. Huh? So that's called as a thermal cycling resistance. So you should have more resistance to the thermal cycling, and it should have low gas permeability. That means it should not attract or it should not provide a passage for the hydrogen oxygen to travel. Huh? And cost and ease of applications. That is major factor. And then chemical stability and durability and compared with the other components of fuel cell. It should not react with the other components. That is another important factor. So we understood, right, about the fundamentals of fuel cells, fundamentals of solid oxide fuel cells, and I have introduced about the materials. And then I also talked about briefly on the requirements of each materials. When I talk about each material, I told you like what are the important factors you have to consider and how polymers are into how polymers play a major role in these factors, right? So now I will detail them in more adequate manner so that you will understand more about fuel cells. Okay, so when we are talking about porosity, remember I was talking about porosity for anode and cathode. So how we can produce that porosity? So you can use pore formers. That is the most common way, but you can use PV foam also to produce porosity. So you see here, this is the PV foam, which can help to, it will act as a template. So you can produce nanostructured porous electrode materials by using PV foams. This is one of the example I have given. There are many templates. You can use block copolymer templates or polymer-based templates to produce porous electrodes in order to improve the gas diffusion. So through the pores, the fuel travels, right? Your oxide ion travels, your proton travels. So if it is dense, they cannot travel. So it has to be porous so that, but this is one of the most advanced way to produce porous. And by doing so, we can enhance the surface area. More the surface area, more the attraction, right? So we can use pore formers to produce porous electrodes, but we cannot say that it will be it can enhance the surface area, or these pores are not connected pores. Maybe pores will be there, but they are not connected pores. They are maybe they create like voids. but that is no use for us. So we need to have a continuous pores. At the same time, it should have nanostructure. So we can use these polymer-based templates. So what I could suggest is, if you are doing research, if you are interested in doing research, you can work on these templates. You can produce templates from your research. You can take polymeric templates as a research topic. Then you can produce templates, and then we can collaborate with various industries, not only in fuel cells, wherever they need a porous materials in terms of supercapacitors or batteries. All these energy devices, they need some porous materials. Even for the purification, air purifications also, or hydrogen storage, all these industries, they need porous materials. So if you can produce porous polymeric templates, it's easy to commercialize, and it's easy to collaborate and do networking. So this is one of the example of role of polymers in SOFCs. And then I talked about fabrication, right, of these fuel cells. I said it's quite complex in when we are fabricating bigger size fuel cells. So when we are fabricating, we go for advanced fabrication techniques, mainly solution-based techniques, where we need to produce inks. So when we are formulating an ink, the solid content of that ink will be like 60% or 65 or 70%. Remaining 30% is polymeric material. We use binders, surfactants, plasticizers. So what these binders do is to improve the mechanical strength, and also it facilitates the ceramic process. So there are different types of binders available, but most of the binders are very, very expensive. And it is we can say that they control the binders. Sometimes we cannot buy from other countries. We can say they restricts the transport of binders from one country to another country because of the uh, trading rules. So this is where we can play a major role. So we can produce our own binders for the fuel cells research. I encourage you to take into research in producing binders for tape casting or screen printing techniques. And we also have pore formers, which creates porosity for gas diffusions, and we have different types of pore formers. So these pore formers will help to produce pores. Okay, so you can take research into consideration. Maybe you can do research on binders and also on the pore formers. So I've given some examples when we are not adequately using the binders. You see some cracks on the surface of the films. So this is a film actually. So we produce some tape casted films, and then we subject them to a sintering process, and then we can see some cracks on the surface of the fabricated films. So to avoid these films, so we have to use the right amount of binders, surfactants, and plasticizers to improve the structural integrity of our films. So this is one of the best recommended area where you can do research related to binders. And then sealing materials. So we discussed about sealing materials in the in the past slides, that when we are talking about sealants, we are talking about ease of fabrication and also cost. So normally sealants undergoes sintering and crystallization, at higher temperatures. So these kind of materials has to withstand thermal expansion mismatches. So when we talk about thermal expansion mismatches, means it should have chemical compatibility between the between the components. That is, when the other components expands, sealing material should also expands at the same rate. If it is detracts, it should also detract at the same rate. If the difference is more, then we'll have the sealants will break, and then it will cause us performance loss to our fuel cells. Yes, and then there are different types of uh, fuel cells available. Of course, sealants are expensive, right? So we have to reduce the cost of the sealants. Then we can go for polymer-derived sealants, and so that we can reduce the cost. And there are different the other types of sealants is based on polymides. Also can withstand more than 400 degrees Celsius, and it can be used for lower temperatures. So when we are talking about polymer-based sealants, we are going to introduce them into uh, low temperature solid oxide fuel cells. And when we are talking about into the whole system, we need some insulating materials, right? Because when we operate at higher temperatures, so the radiant of heat will be more. So to the surrounding, it will be more, right? So in order to insulate the surrounding, we can use polymer ceramic insulating coating materials to avoid the thermal gradients or the loss of temperature from the to the surroundings. So what are the research opportunities and challenges available? So in terms of SOFCs, there are some technical issues such as commercialization, high temperature, fabrication difficulties, components durability, and startup time. Economic issues we have, environmental issues we have, social political issues we have. So all these issues can be solved based on right focus of research. So we have to identify different types of cathode materials which can give better active sites for oxygen reduction reaction, and different anode materials for hydrogen oxidation reaction, and different types of apparent materials which can have higher ionic conductivity, and we can optimize their material properties such as composition and microstructure. And when it comes to fabrication, we have to identify various factors, and we need to adopt advanced characterization techniques in order to enhance the performance of SOFCs. So how the polymer scientists will help into these? So when we are into um, challenges, the main challenge is the degradation of polymers. Okay, so when I said that when we want to formulate inks, we need to add binders, right? So we have to identify binders which can be decomposed at lower temperature. And also when during decomposition, it should not affect the original properties of our anode or cathode electrolyte materials. So we have to identify the right amount, polymer materials, and also at the same time, this material should not leave any kind of organic residues in the system that will affect the performance of the cells. So we have to, these are the challenges you have to consider. And but still we have some opportunities that you can develop the binders for the few for ink formulations for SOFCs applications, and then sealing materials. And also we can explore on the biodegradable polymers for sustainable SOFC manufacturing so that it can decompose faster. And you can collaborate. That's why I said collaboration is very important with the industries and the educational institution. When it comes to career opportunities, from polymer engineering, you can move on to the material scientists, especially on the energy materials. You can do lots of R&Ds, and then you can do R&Ds on fuel cell and hydrogen energy industries, so that you can build on advanced polymers for clean energy. Okay, so I would like to conclude my talk based on based on my slides. Like as I said, I introduced about fuel cells, and fuel cells are clean and efficient energy source. Uh, when integrated with polymer, the efficiency can be improved. So you have lots of opportunities in terms of research and from binders to sealing materials, and also on templates. Especially on the templates, you can concentrate. So what we can do is we can create some bridging activities here between polymer science and polymer technology, so that we can initiate new research in this field. And I would say that there are numerous career opportunities are available for polymer technologies in the field of fuel cell and clean energy industries. Thank you so much for listening to me, and I open the session for questions. If you have any questions, you can ask.
Sir, as we were discussing, is there any additives or fillers which are recent breakthrough in the technology and which provide high efficiency in energy storage in the current market? Is there any breakthroughs or new materials right now introduced?
There are breakthroughs for the same materials. Actually, it depends on how it's been synthesized. So the list of materials I have shown in my slide, that are the most commonly used binders. So if you can do research on similar material but with different particle shapes or sizes, that will be more helpful. So that's where the major part plays. So they the major producer of these polymers are from Sigma or Merck. So they are they control these products. So what we and then they fix the prices. So it's quite expensive than to purchase from them. So so we can concentrate on these materials. Then we can produce materials of similar properties, and then we can use them in fuel cells research.
And one more. And one more, as the world is turning towards sustainability and circular economy, incorporation of bio-based and biofillers, as you were speaking, is okay, but will that also diminish the performance of the polymers as well? So,
Where in fuel cell technologies, we use polymer as a template. Polymer will not play a major role in terms of performance. We use polymers to fabricate the fuel cells. Understand? Whereas if you are talking about low temperature fuel cells like polymer electrolyte membrane fuel cells, say they use membranes which is completely made up of polymers. Who is producing that? DuPont is producing. We call that Nafion membrane, and then they have patented it for so many years that no one is allowed to make such similar. Means no one is allowed to cannot make a Nafion membrane. But what people are doing is they are doing research to produce similar property, means similar to Nafion. They are into the research to produce a membrane which can perform similar to Nafion, so that we can stop depending on DuPont Nafion membranes. So when it comes to solid oxide fuel cells, we don't use much of polymers, but we take aid of polymers to produce the components, to fabricate the components. Whereas in alkaline membrane fuel cells or anion exchange membrane electrolyzers or proton exchange membrane fuel cells or polymer electrolyte membrane fuel cells, they employ polymers directly as an electrolyte. So there is a lot of space into this kind of research. And also I'm talking about templates. Template is one of the most important currently, not currently, it's been researched for quite a number of time, but more recently research on template synthesis of templates is it's getting into um, uh, a major field, because the number of applications are high when we talk about templates. So we are moving into the sustainable or clean energy source, right? So we need to store hydrogen. So we need these templates to store hydrogen actually. So we synthesize the templates, and then we produce the hydrides, that helps to store hydrogen. So these hydrides, metal hydrides. So normally we call them metal hydrides or semi-metal or hybrid metal hydrides. So we take use of these templates to produce nanostructured or nano wires or nanotubes, and then we store hydrogen into it. So template research on template is very important that you can consider. And also if you are into research on membrane side, conducting ionic conducting membranes, for example, or proton conducting membranes. Some of the polymers are conducting polymers, right? So you can make use of those polymers to produce oxide ion conducting membranes or proton ion conducting membranes for fuel cell research, and also for the electrolyzers. Electrolyzers is the opposite side of fuel cell, where you give water, it gives you hydrogen and oxygen. So, there's a two different ways you can use membranes in this clean energy technologies.
Thanks.
Good afternoon, sir. I have a doubt on what kind of materials we can use for coatings, the outer layer, and will it have a huge effect on the functioning of the whole cell?
Coating, what type of coating are talking about?
The material coatings, the final coating, will it actually have an effect on the functioning of the cell?
Yes, when I showed you, this is the fuel cells, right? So this anode or cathode is being coated using screen printing or tape casting. So, this particular cathode materials is constitute of 60 to 65% of solid content, whereas 35% constitutes to the binders or plasticizers, surfactants, and solvents. So the combination of these 35% is very, very important. So we have to use the right amount of binders, right amount of surfactants, right amount of plasticizers, and right amount of solvents. If the ratio between these is not adequate, then we will have cracks. Uh, uh, the layer I'm showing here, it can fail. So even though if you use the right amount of binders, but if you're not using the right binder, right one, still cannot. And you use the right binder, but you didn't use the right plasticizer, which is compatible. Binder, plasticizer should be compatible. That's why fabricating this is not possible in every labs. It's very, very tedious process, painful process. And then if you're successful, you can easily commercialize. So, of course, coating matters, but coating subject to types of coating, means the technique used for coating, that is also important factor. But ink formulation is also important factor. So we have to consider both manufacturing, manufacturability, the techniques used to apply the coating also we have to consider. Have you come across, do you know about tape casting, screen printing and all? Right? Okay, the tape casting is like this. I'll show you. So this is the tape casting. So this is the tape casting where they mix the powders, then they add the organics and um, uh, additives, and then they do the mixing process. Then they pump in. Then they use Dr. Blade. They apply the coating, and they do the drying. Then finally they do the sintering. So after drying, we have to cut them into desired shapes. So if you want 10 into 10, we cut them into 10 into 10. But we will not cut exactly 10 into 10. We have to study on the shrinkage properties. You know about shrinkage, right? When you heat, it will shrink. So we have to consider that factor, and then um, so we cut into desired right amount of dimensions, then we sinter, and then we get in 10 into 10 or 15 into 15 or 20 to 20. Like. Welcome.
Sir, how can a polymer-based fuel cell components to be designed and applied in extreme conditions such as deep sea or space exploration, sir?
Yes. Do you know about the Apollo tragedy? Apollo mission tragedy, where the rocket exploded and astronauts died. It's why it happened. Have you studied the case study of that? It's simple. It's failed because of the failure of the gasket. That important, a small component, it's failed, and then the disaster happened. Apollo disaster, I feel. Yeah, Apollo disaster. So polymer plays a major role. If you are running a fuel cell, and then your sealant breaks, your whole system breaks. Understand? So it's very in fuel cell research, or in hydrogen production, or in battery research, or in supercapacitor researchers, polymer plays a major role. But I'm not sure whether you have come across about supercapacitors or membrane technologies in your degree programs. But I encourage that you can start studying on that. Maybe you can consider doing research for your final projects, so that you will come across the major applications of polymers.
Sir, good afternoon, sir. Sir,
Doctor.
Sir, what is the durability factor for oxide ion conducting electrolyte and proton conductor electrolyte, sir?
Okay. When it comes to durability, we are talking about thousands of cycles. More the durable is the better. So we have to design in such a way that it can run for thousands of cycles. But the beauty of fuel cell is like it's like our body. Huh? Our body is made up of millions of cells, right? So if one cell damages, what happens? You repair that cell, right? If you had a cut or if you get a rash, you apply medication on that particular spot, right? Means you're not going to apply on the whole body. Same way, if a cell breaks, we just replace that particular cell. So the durability of the system, we are talking about the durability of the system here. It's not the durability of the single cell. If single cell breaks, we replace that particular cell only. So that in that sense, we can improve the lifespan of fuel cells.
Our heartfelt gratitude to you, sir, for such an intellectually stimulating lecture on your theory cells. Your profound insights have provided us with a fresh perspective and renewed motivation to strive for excellence. As a token of appreciation, I now invite Mr. Nitin Srinivasan to deliver the vote of thanks.
Good afternoon to one and all. It is my pleasure to propose the vote of thanks on behalf of the Department of Polymer Engineering and the Association of Polymer Engineers and the School of Mechanical Sciences. First and foremost, we express our sincere gratitude to the Almighty for His blessings in bringing us together today to share knowledge, celebrate achievements, and strengthen our academic community. A special thanks to our distinguished guest of honor, Dr. Muhammed Ali. Your expertise in fuel cells, electrolysis, photodegradation, wastewater treatment, and CO2 conversion has been truly inspiring, and we are grateful for your time and effort, sir. I also take this opportunity to thank our Dean School of Mechanical Sciences, Dr. C.G. Jailani, sir, for his continuous motivation and guidance towards all our departmental activities. A special note of gratitude to our beloved professor, Dr. B.S.Abdur, sir, for being a constant source of inspiration and encouragement. A sincere thanks goes to our head of department, Dr. S. Kamshat Begum, ma'am, whose leadership and unwavering support has been the backbone of our success. We also extend our deep appreciation to our faculty coordinator, Dr. J. Saida Parveen, for her tireless efforts in making this event a grand success. I would also like to thank our faculty members, Dr. Crescent Kumar Verakar and Mrs. Lourdes Banu ma'am and Mrs. J. Daphne ma'am for their valuable guidance in organizing this event successfully. A special thanks to our student coordinators for their relentless dedication and effort in making this event possible. Last but not the least, I thank all my fellow students for their energetic and enthusiastic participation. Your involvement has made this event truly memorable. Thank you, one and all.
Thank you all for your presence and participation. Wishing you a great day ahead.
Thank you, Prof.